have a demand and supply functions with the axes interchanged, but that doesn't matter. Here we have the quantity and here is the price. The demand goes down because the bigger the price, this bigger the price, which is here, the smaller the quantity. At this high price, nobody will buy, and a little bit less people will buy. Similarly to the supply, the bigger the price, the more producers are willing to supply. So the order of the axis is interchanged, but the graph makes sense. So the question is, given a supply and a demand and a marketing equilibrium, how much people make extra or how much people save extra? That's the idea of the surplus. For example, here, first of all, we need to know what is the equilibrium point. As usual, given the supply and the demand, the intersection is the equilibrium point. As we're taking quantity on the horizontal axis, this will be the equilibrium quantity, and this here, sorry, not very straight, but that will be the equilibrium price. What is happening? What's happening here in this moment when we have quantity and price, and this is the demand? If this is the equilibrium price, what happens? People are willing to pay this much here. They will buy this quantity at this price, but the actual selling price is here, the equilibrium price. Therefore, consumers are saving this much because for this quantity they will be willing to pay this much, and they're paying only this. Similar here and here, or in all this line. So eventually this area is the cumulative saving of consumers or consumer surplus. Similarly, for producers, if this is the supply and here is the equilibrium price, what you have to understand is that producers are willing to sell at this price and people are buying at this price, so they're making this extra money. Putting all quantity together, here we have the producer or supplier surplus. And how do we compute this? These areas by integration. Do we compute these areas by integration? Of course, now we know that the integral is the area. We can easily compute these two surpluses as follows. For the consumer or consumers, whatever surplus, what we have is quantity, equilibrium quantity, equilibrium price, and this area, given that this curve is the demand, so the area or the surplus of consumers is giving us the integral between 0 and Q star, 0 and equilibrium quantity of what? Of the upper curve, which is the demand, minus this fixed line here, which is the equilibrium price. Regarding the producer or producers or suppliers, what we have here is a supply and a price. So this area here, as this point is the quantity at equilibrium, this area is computed as the integral between 0 and Q star, between 0 and Q star of the upper curve, the equilibrium price, minus this one here, which is the supply. So let's consider the example we have seen in class, well, in the virtual class, where the demand was given by 25 minus Q squared for the demand. You can see for Q equals 0, this is 25 and goes down like this. The supply here in this example was given by 2Q plus 1 supply, and is a line when Q is 0 is 1, so it's this line. So first of all, where is the equilibrium point? Equilibrium is reached when the demand is equal to supply. 25 minus Q squared equals to 2Q plus 1. And here, moving this thing to the left side, we have Q squared plus 2Q minus 24 equals to 0. So Q is equals minus B plus minus square root of B squared minus 4AC divided by 2a, which is minus 2 plus minus 10 divided by 2, which is minus 1 plus minus 5, and minus 6. This is not a quantity because it's negative, and 5 minus 1 is 4. This is our equilibrium quantity. To compute equilibrium price, well, as we have said that demand is equal to supply, we can replace this quantity of equilibrium in any of the two, demand or supply. Doing it in the supply when Q is 4 is 2 times Q plus 4 equals to 9. So price at equilibrium is 9, quantity at equilibrium is 4. How do we compute the surpluses? So let's go for the consumers. Will be the integral. Remember, here is your price, your demand, so this area, and here the quantity at equilibrium. So this is 4 and this is 9. So this is the integral between 0 and 4. You're integrating the x-axis here of the demand minus equilibrium price. So it's the integral between 0 and 4 of 25 minus q squared minus 9 dq, and that's equals to the integral from 0 to 4 of 16 minus q squared dq, that's equal to 16q minus q to the third over 3 between 0 and 4. And that's equals to 16 times 4 minus 4 to the third over 3. And this quantity is 4q equals to 4. And you have, by the fundamental theorem of calculus, you have to do the same when q is 0, which is 0 minus 0. It doesn't matter, it's 0. You just write it to get used to that you have to put both ends. Now, doing the computation, this is 64 minus 64 over 3, which is 128 over 3. What about the producer? See, if we go to producer, we have that the integral is now the equilibrium price, which was 9, the supplied, and here is the quantity. This is a triangle, so you can actually compute the area by geometry, but let's compute it by integration. That's the integral between 0 and 4 of the upper curve here, 9 minus 2q plus 1, which is the supplied curve. So that's equals to the integral from 0 to 4 of 9 minus 1 is 8 minus 2q dq. So that's 8q minus q squared from 0 to 4. So that's 8 times 4 minus 4 squared minus 0 minus 0. Let's underline this thing clearly. Here is 4q equals to 4, and here is 4q equals to 0. Back to the blue, and we have this is 32 minus 16 equals to 16. So surpluses in this case are for consumer 128 divided by 3, and for producers this is equal to 16.